very important, and it uses the extremely change of temperatures between the day and the night. In Mars, we have a rate of change in temperature like 100 degrees Celsius. So we want to make the most of it by play with the pressure of a gas. So in the night we'll have a compressor that it's compressing the CO2 of the atmosphere, and the CO2 liquefies, and you retain it liquefied in the night. And when this system is in the air outside, and in the day the pressure get up a lot, so you open and you have a lot of energy of this gas, because it goes liquid to gas. So we have using the batteries, the two types of batteries, and the generator. So maybe you have like alternatives like solar panels in the day, and the power that the solar panels take is kept in one of these batteries, and in the night are used to make work the generator of the campus. So we have a solution of energy and of power, but let's put it all together. We have, this is our final purpose. We have types of energy like the work of man with a pulley system, and solar panels that generate the energy and we retain the energy in any of the both batteries that we have talked about. In this case is the compressor and with a tank. So this energy, it's keep it underground, and because we have the solar panels only in the day, and we keep the energy, and in the night this energy are used to make work another compressor to retain the CO2 liquefied. We have a tank of liquefied CO2 outside, and in the day we use this CO2 by the change of the temperature to make work a turbine that generates electrical energy. But this turbine, it's inside the dome. So we get together the two ideas. So we have in the dome, we have a stable temperature with a stable pressure that it's provided with this system that also generates energy. As a conclusion, we think that this is a solution, a viable solution for Mars, that it's very simple It
Is cheap and is easy to repair if any of the system fails.
Yeah. Also, we think about, okay, we need energy, but the energy like solar energy, like wind energy, the energy of the wind, are only in the day, and we need unstable energy, and the nuclear energy, it's a good idea, but it generates a low amount of energy, and it's hard to take to the space. No, it doesn't hard, but it's more efficiency in this.
And we want to focus on a system that we can use the materials that are in Mars and not to bring from the Earth.
Thank you guys. Are there any questions?
I have a question real quick. You said you split the two boxes inside each dome and you had multiple domes, and you did that to make sure that nothing got like disease between the two. So what happens when something dies? Do you start over with that box and plan new things eventually, or do you just let them die because you have so many others? Like what do you do?
With the plans
Something
of
happens
a specific
in a box. Yeah. You said you guys split it, right? Because you did one perspective.
Yeah.
Something did happen. So if something, even though you have a lot of these domes, you have one of these boxes, what happens to that? What happens when something bad happens?
Oh, the idea is we have separated, and if something happens to one, first, it's not a problem, because the idea is to have enough to make the human survive with the other time of the other bomb on the other side. ISS green grasses, how the plants are affected by fever, and also it's a risk. It's a risk that these solutions work together. Okay, guys. So thank you very much, everybody. Thank you to all our judges. We know that we take time from your agendas to be here. So you kids presented really incredible projects. So you should be very proud of what you did. Our judges will discuss, and tomorrow they will tell us which